So we have a MacBook Air. It says no power, but it has further description here. It says faulty battery, dead motherboard, not charging, corrosion on I/O board. Okay, so let's see what we have. First and first, let's take out the back cover. We will not connect the charger until we can confirm it is safe to do so. Okay, back screws are out. Okay, this is clearly a liquid damage. This is a clearly liquid damage device. We have signs of corrosion here. Yeah, this is a liquid damage device. So definitely it's not going to be a good idea to connect power to it. Is we have to take the board out, address the issue before we even think about connecting power to it. This is one of the reasons why it is not advised to. We have one missing screw here, one missing screw here. Yeah, I suppose someone has been there before. So this is why it's not ideal to basically connect power to your machine until you are sure of what state the machine is in. Okay. So the one of the common mistakes that I see people make regarding um, the Wi-Fi cable aligning, it's people tend to so the Wi-Fi cable has to be on top of the heatsink, so it has to go over the heatsink. The screw that holds it down has to first be put in place before this goes over. So if not, what usually happens is you see this crack on the cable. This is caused by the screw. This is caused by somebody trying to um, run the screw with the cable already over the heatsink in that section. So the ideal way is lift the cable like this. Put the cable to your left and then install the screw, and then the cable can go over it. Not you don't the cable shouldn't not under it, not over it, and then trying to put a screw through it. No, you put the cable to the side, disconnect it, put it to the side on your left hand side, install the screw, and then the cable can go over it. Not having it not routing the cable first and then trying to put the screw on the side, because by so doing you may create what we see here, which is this cracks on the cables. So this is not how it should be done. Uh, and also we actually see that also the screw that was there is missing. For some reason it was taken out and was not put back. They were saying something about liquid on the iron cable, so which is that. And then I think they also said something about not charging. It's not charging. So yeah, so that that's okay. Yeah, you see why that is. So I'm just gonna confirm something. I want to see if our PP. So let's open up the board view because so with the JTAG we can tell this is a 2015-2017 board, and the board view it's going to be 820.00165. Um, this is the connector J9500. Now the signal I want to confirm if it's present, it's going to be our where are you? You, okay, sys1 wire. So, so sys1 wire it plays a vital role in generating the communication LED, the communication light we see on our charger. So, um, so two things I saw. So first thing is there's liquid, there's corrosion on this section of the cable. So that, and also the connector itself. You see that the connector itself is corroded. So which means that cable might the pin there might have been damaged, which means the communication between J9500 pin and 61 wire, including PPW42, may also have been damaged, severed from the board. So what I want to do is I want to connect the charger to see if I get LED on our charger. I'll give you an idea if say okay, we don't have LED on our charger, but the fan spins. So there's no LED on our charger, but we have a fan spin. And then let's say the machine actually powers on, but then immediately goes to sleep. So the machine powers on, and then it immediately goes to sleep. So I'm just going to show you guys what that looks like, and then I will explain shortly why that is the case. So we don't have LED on the charger, so this one wire will not function. I mean that light. So in this state, the battery obviously will not charge. So let's see, okay. Let's see, do we have? hmm, Okay, so the reason why that will be the case is on that section of J90 9500 where I showed you guys, there is also this signal which is SMC lead. Now SMC lead is it's the line, the data line that tells the SMC what angle the lead is. So when that signal is put, that signal is by default that signal is supposed to be high. The way you tell the SMC that your lead is closed is by shorting that signal to ground. Now, because there is liquid in that section of the board, that signal is going to be low. The signal, as it is now, we'll see that SMC lead is low. Now, when that happens, I'm just gonna. So that signal is supposed to be 3.3 volt. Let's just switch this. It's the other side, SMC lead. So here we can measure SMC lead on this pin here, the first pin. Now two things. So we may have SMC lead present here, but then we may be missing the signal here because of the broken pad due to the corrosion. So let's just see this pin 1.9. That is actually low. The SMC lead signal should be 3.3 volt. Now, what is pulling the signal down is going to be our cable. Will be playing a role in pulling the signal down, because the sleep sensor is also going to it's on our IO board. The sleep sensor is here. So if for me to basically bypass that, I will have to disconnect the IO board cable. So with IO board this cable disconnected, the sleep signal should be high. So what I'm going to do is I'm going to disconnect the charger, disconnect the IO board cable. Now we try it again. So this time the signal should be high, and not only should be will be signal be high, also the backlight should be on as well. So let's just see if that's the case. Okay, so let's see. Okay, now not sure if you guys can see. Now we have backlight. Backlight. Let's just see. Uh, but now I don't know if you can you see that? Okay, but first let's just check what the signal is now. Initially we saw the signal was 1 point something. Let's see what it is now. Now it said that is 3.3 volt. So now we can see that the backlight signal is high. So because of the corrosion on our cable, that will pull the signal down to 1 point something volt. And then when it pulls the signal down, the SMC will assume that the lead is closed. SMC assuming that the lead is closed will basically put the device to sleep, which is, uh, so, yeah, I mean, you guys can see that, yeah? So that was not the case before. So now the next thing we want to do, so in addition, but then also we see that in this particular state, in this repair, this needs to be replaced. We also need to replace that connector, otherwise there will be no the device is not going to charge, and also the SMC lead signal will be pulled because if this is connected, obviously if it's not replaced, and even if this is replaced without communication being so even if this is replaced, most of the signals on this side from pin 29 to pin 19 are damaged. So even if you replace just this without having to replace the connector, most of the signals here will not be active because of the damage caused by corrosion. So the next thing we want to do is, in addition to addressing the other sections of the board that are corroded, we will also have to replace J9500. So see this corrosion here, corrosion there. Now, the corroded section of the board, some of it will be critical. So if we start from the right hand side, we say we have corrosion here. Now this is a 2017 board. One of the way we can tell that is because it's a 1.8, and then also the camera, the image processor IC that is used here as well. So we have a bit of corrosion this side, we have a bit of corrosion this side, we have a bit of corrosion that side. Okay, and then we have a bit of corrosion here, and a bit of corrosion here. The first thing we want to do is we want to replace that. First of all, uh, let's bend this so that it realizes not to be pulled back. Let's remove the SSD. For some reason, the machine was showing. Not sure if SSD. There's a bit of a corrosion also on the SSD. I'm not sure if that. It's 128. Okay, let's then first let us remove. Let's remove and replace J9500. In replacing J9500, we try to move our hot air away from the webcam connector, which is this one, so that we don't damage it. Okay, so let's clean that section of the board. Primarily, the main signal that was affected is the 6-1 wire, 1, 2, 3, 4, 5. So which is if you count from here 1, 2, 3, 4, 5, P342, and then 611 is going to be the first one. So the PP342, so the PP342 it's there, and then let's say PP342, no, 611 is present, but the PP342 signal is not present, which is on this line. So what we and then also we have one two this is also affected the SMC lead signal, yeah. So SMC lead signal and then PP342. So what we want to do is we want to try to review our pad. Okay, let's apply a bit of solder. Okay, let's get a donor board to get back. The connector from a donor board. Can use this one. This is out already. And we can use this. Looks good. So now to harvest that connector, we have to do it from the bottom of the board because we can't do it from the top, but that would mean we have to reduce the amount of heat that we use. and that will take quite some time. And we don't want to go through the wait, so we rather take it from the bottom. That's quick. And also, when you're installing it back on the board, you follow the same process, which is to hit the board from the bottom. And also that you can also do it from the top, but then you run the risk of melting the plastic section of the board of the connector. And if you don't want to do that, if you don't want it melted, you can do it reducing your hot air, but that also will take time. So to be safe, you rather have it done from the bottom of the board. Okay, it's just yeah, that's enough. I just wanted to confirm if PP342 is present on that pin that was broken, just so we don't um, just to be sure before. So if there is a need for us to recreate it, we can do that while it's still out. Okay, PP342 is present. Okay, that's fine. PP342 is present. Okay, so if this connector is not properly replaced, some of the evidence signs you will see at when the IO body is connected, the functions on the other side, most of the functions on the IO board section, which is here, will not be present. So number one will be sound, because the audio IC is on the IO board here. So this is the audio IC. So that is not going to function properly. Now the lead, that is the lead sensor. That this is so some of the functions here. So that is the lead, the SNC lead. That's a sleep sensor. That is not going to function properly. Sounds, that is not going to that may not function properly. And then also when it comes to the sys1 wire communication, which is how the charger gets the LED on, or the charger gets LED on. That also. So these are the three main functions that we will see that will be absent if the IO board cable is not properly connected, is not properly installed. Then another thing we want to look out for is uh, this also looks to need replacement because of the way it looks. So also to be safe, let's also take that out and then point out to them that it needs to be replaced. The client needs to know that that also needs to be replaced. So in addition to the connector being replaced, if the connector is not properly replaced, those are the immediate functions that will be lacking from it. Okay, so this IO cable also needs to be replaced. Now let us uh, let us see if we have sound. See if the device goes to sleep with the lid being closed, and also to see if we have communication on the charger. I'm just gonna grab another PCA board and IO cable. You can just check it from here. Right now, we want to see if we have sound, and also if the fan does not overspin. Also, yeah, that's another thing to. It's another way to know. But definitely, we need to make sure the cable is connected. Okay, let's take. Can grab one. Okay, test them first. Let's see if we have LED in our charger. Okay, that's good. We have LED. And then it also goes to amber, which is good. Now let's see if we have sound. That's good. Then the next thing is want to see if the fan overspins. Oh yeah, the fan might overspin because this is not connected. Let's have it connected. Let's check again. The keyboard. What do you mean the keyboard? We don't need keyboard to work. As the trackpad. So okay, so just clean that section of the board, and then just to be safe, let us run our soldering iron through it. Also try to move it just a little bit to the side. Let's try to replace the components that we created here. See what the resistance is on the other side by the SMC. So it's this and that. So it's in one. Okay. Okay, I'm not going to reuse the part here is broken, so I'm going to create an alternative part for it. It looks big, but that will do the work. Okay, it's there, it's placed. It's in its place. Okay, then the next thing is this section of the board here. Let's see. First. What is that? Is that section 4? That is all sys power good. Let's try to replace that. Okay. And then this is a little bit to get the edge banding off. Okay, let's clean the board. Okay, let's also remove the JTAG. Um, that may cause a problem for the machine in the future because I see there's a bit of a traces of corrosion on the paint. Should also go. Okay, that doesn't look good. Let's reset. Even though it's not faulty now, just to be safe. Okay. 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 It's a big brush. Okay, our board is clean. Let's just see if we still have a final stain. Okay, let's see if our board is posting. Okay, our board is posting. Just going to confirm the voltages 1.8. Yeah. So that's yeah. So this is fixed, and basically so our main issue was at the section of J59 9500, and the signals that were affected mainly were PP340 signal and this SMC lead signal. So the reaction of that was machine would not charge. The machine also would assume that the lid is closed even when the lid is open. So we addressed that, and then on that side of the board, we found a couple of components that corroded. We had to replace them, even though they were not immediately posing any threat to the machine. So such components, I'm just gonna quickly. Uh, um, Such component. Okay. Mm. Soft. Okay. Yeah. Such components include U1845. We replace that, and then the two SMCs by the SMC, two resistors by the SMC, R5198 and R5230 we replace, and then we replace a MOSFET on the other side, which is Q7520 also we replaced. Yeah, pretty much that was it. And then we had to clean out some of the less damaged, less corroded sections that we found on the board, and that marked the end of our repair. So the next thing we're going to do is Peter is going to put this board in a different shell, just make sure the device is 100% okay. As you see, the client is shell, the IO board cable and the DC jack needs to be replaced. Let's see if the cable is fine. Yeah. So the IO board cable and the DC board cable also needs to be replaced. So Peter will have to put this in a differential, test it, and just to be sure, three minutes to confirm the machine doesn't get stuck on sleep, the fan doesn't overspin, it has sound, and yeah, pretty much. You can also put in test SSD just to be sure that it's not slow. I think actually that would be ideal. Put in a test SSD to do the test. You can use you can use you can use that shell. And you just use any shop. But for this one, get an updated operating system from get something higher from Alex, and just copy and paste the update on the desktop